Welcome back, friends. Today we are going to learn about some interesting topic called AWS Code Pipeline. Basically, AWS Code Pipeline is a fully managed continuous delivery service that helps you automate your release pipelines for fast and reliable application and infrastructure updates. So basically, what you would do in this AWS Code Pipeline is it is a CI and CD tool where you can integrate it with your source code like GitHub or AWS code uh, repository, and then you can build the code, you can run the tests, and then deploy it into your environment of your choice like a EC2 or a EC2 auto scaling group or a ECS, and then you can also set the logs to CloudWatch and different monitoring systems. So very helpful framework. So, and we have also it also includes AWS CodeBuild and AWS Code Deploy components. So we learn in a very easy way or a simplistic way how this can be implemented to deploy a Spring Boot application that has a PKCE authentication framework that we saw in one of our earlier tutorials, and it will also have a interesting KMS encrypted property. So uh, uh, today's session would be about demonstrating how we can deploy Spring Boot microservice with PKCE authentication. This part we have already seen in an earlier video, but today we are integrating it with KMS encrypted properties in application.properties file, and then we'll deploy it in EC2 using AWS Code Pipeline. So we are doing a lot of things in today's session. So, but I have given detailed instructions in my GitHub readme file. So this is my repo for this, and all of this is checked in, so you can go through this. Basically, we need to have a Spring Boot application. This is the same Spring Boot application I used to demonstrate the PKC authentication flow, and we have added certain files there. I'll just go through them quickly. So we have a appspec.yml. So these files help in the AWS Code Pipeline configurations for AWS Code build and code deploy. So basically it is saying that this is the folder structure, this is the destination in the EC2, and gives the permissions, and then when the EC2 is before it is created, before application is installed, it will run some shell script files. While after installing the application, it will run a particular shell script. After the application starts, for the application to start, it is running another set of shell scripts, and when to stop the application, it does run another shell script file. So let's go ahead and see what these shell scripts are. So it is in the scripts folder. So basically this is giving permissions for these shell script files, and then the other file is deleting the entire data, clearing it up, and then this is for the starting the Tomcat server. So basically this is basic Java JR and using the port 80 to communicate with the microservice. You're using for the access logs, we are setting some environment variables and the jar file that is created as part of the code build process, and the output is going to a null directory. So pretty much that's what the scripts are. And then let's go through the build spec.file, which will be used by the AWS code build component. Basically it will use Java 11 to deploy or to deploy on the EC2, and then it will run MVN test and MVN package, and once the build is run, it echoes build completed, and it is mentioning that all these artifacts are there. So that's about with the additional files that we added to support the AWS code pipeline and code build and code deploy components. So if you go through the pom.xml, we have already gone through it. In addition to the PKCE related stuff, I have added this org.zalando helper library that is used to unencrypt, decrypt the application.properties the password configuration password property using the KMS related key. So that's all we have here. And let's go into the source and see the application.properties file. So if you go into the application.properties file, as you can see, we have a encrypted password here, and the username is John. And let's also see how they are being used in the Java class. Earlier in my demo, the password was not encrypted, but for security, you need to encrypt it. So if we go into the security config, we are auto wiring the username and password here, and that's all it takes. So the added library automatically decrypts it. And there is a bootstrap.yml for KMS library to unencrypt and decrypt it. So that's all are the changes that we made to our PKCE application, and now it will be ready to be deployed using AWS CodePipeline. So basically, we have created a Spring Boot application and we have pushed it to GitHub. We'll edit it so that we can get a better readable instructions. We have added the appspec.yml, buildspec.yml, and we need to create IAM roles, one for EC2 and one for code deploy. The EC2 role will have 4 permissions: Amazon EC2 role, Amazon Key Management Service for KMS. This is for EC2 for the code deploy. This is for CloudWatch, access to CloudWatch logs, and this is for S3. And then we create one more role for AWS code deploy. Once we also create a key. So let's go ahead and see the EC2, and this is the role that we created. And sorry, this is the role that we created for assigning to the EC2 IAM role field, and these are the permissions that we mentioned that we assign to this EC2 role. Other than that, we haven't done much in this particular role. The rest of it is like we just have enabled the port 80. I enabled 8080 also, but that's not required. I just enabled 80 so that we can call the microservice. And this will be our public IPv4 DNS, and we have a IPv4 address as well. So now let's go back and see what else we need to do. Then create a role for create a key for KMS key basically. So how do we create a KMS key? So so I have already created a KMS key. So this is the key, and as you can see, it is being used by this EC2 role, and it is using a symmetric encryption. Basically, symmetric means you don't have two different keys, public key and private key. It's a single master key that is used to encrypt the data. So using this key, we are supposed to create a encrypted password, right? So let's look at this section, generate the encrypted password section. So what we are doing is we need to configure a AWS profile for generating the encrypted data. So once you enter this command, it will ask you for configuring this, like okay, we'll open a new window. Using the PEM file, we'll log into the EC2, and then I have already installed AWS command line tool. I'll to show you in a few seconds how to do that. So if you do that, it will ask you to enter the AWS key ID, and then it will also ask you to enter the secret key and default region. Don't worry, this is fake data, so I'm okay to show that to you. So basically once you configure that, you need to export that profile, and then using this command and the key ID that you saw earlier, you can encode any kind of plain text, like this could be any property data, like any kind of client ID or secret that you want to hide. So once you are using this key profile, so it creates this data, and this is exactly what is there in my application.properties file. So once you add it to your application.properties file and using the generated encrypted data, your application is basically checked into GitHub and it is ready for deployment. So we will also check this code deploy role in a few seconds. So basically we launch the EC2 and we keep the port open and install the code deploy agent using the section prepare EC2. So what we have to do is we have to bootstrap the EC2 with a few basic software. So we are updating the M repo, and then we are installing wget, and using wget you are deploying the AWS code deploy agent, and then you are also installing JDK 11 for our application to run, and also AWS CLI. So because we have installed AWS command line interface, it is able to run these AWS commands. So just to verify, I have already prepared the EC2 with these commands. These are straightforward commands you can run and it will prepare your EC2. As you can see, my EC2 is already set up with Java 11, and also the code deploy agent is also running using this code deploy wget command and install. So then I'm setting up this profile on my EC2 like I mentioned earlier, and I'm also exporting this profile. So for preparing the CloudWatch, I'm running these commands as well, and I have a AWS CloudWatch agent.json file. I'll show it to you in a few seconds, and I'm copying it in a particular location in my config folder in my EC2, and using that I'm starting the CloudWatch agent. Basically this will send the logs that are mentioned in the log file, which is mentioned in the AWS CloudWatch agent.json to CloudWatch. So let's go ahead and see what is this CloudWatch agent.json file. So basically what I'm saying is it's a very simplistic one. You could have multiple loggers. You can configure Spring profile to point to dev, production, QA, etc., and you can give multiple configuration files like this. So right now I'm using a single log file which will be in my server my.log file. I mentioned provided the path to the my.log file and the name of the log file in the application.properties file, and then I'm giving a log group name which AWS CloudWatch will automatically create. So let's go ahead and see what is there in the application.properties related to this logging. So as you can see, I'm giving the my.log file here. So let's go back and go to the readme section. So that's we have created the EC2 and also executed the steps mentioned in this prepare EC2 section to set up code deploy and AWS command line interface, and also Java, and also a KMS key profile, and we have exported the KMS AWS profile, and also we have set up CloudWatch to log the data or log file data into the CloudWatch repo. So next we will see code deploy. So we'll create application in code deploy. We will we'll give a name and we'll select the EC2 as on-premise. Basically it's not a standard EC2. That's what we are saying by meaning on-premise. We will give a name to the deployment group, and the role will be the role that we created for code deploy in this step. So here we created a role, AWS code deploy role. So that is what role we will assign, and the deployment type will be in place or blue green. In place means basically the the servers or EC2s will be updated, and then they will face the traffic right away. So but in blue green deployment, you will create the old one will be still receiving traffic, and you will create the new one. You will set them up in the load balancer, and after it is set up, then it is taking traffic, then we will decommission the old set of instances. But here they are for this particular demo, I just choose in place. You can choose blue green as well. Choose the tag for EC2. For basically mention a tag that we mentioned while creating the EC2 to deploy our application. This is simple setting on EC2 when you are creating the EC2. So let's go ahead and see what is there in code deploy. So basically, this is the thing we have mentioned earlier. In place deployment, the application name is, we have mentioned the KMS demo app and on-premise EC2 and all at once code deploy default. And this is the service role for the EC2. And this is the, basically we are saying in this code deploy that we are taking the output of the code build and we will be deploying it on the EC2, this particular EC2. That's all we are saying here. Now let's go back to our set of instructions. Now we'll set up the code pipeline. So basically we again give a name to it and create a service role, new service role, which is a standard bootstrapping thing. And we choose, because our code is in GitHub, we choose GitHub as the source and authorize AWS to Git repo and select AWS CodeBuild as the builder. And we will then create a code build project. So let's see what we are trying to do. I already did it for us. So let's go ahead and see code pipeline. It's very simplistic once you follow the instructions. Basically what we are saying is we have given the GitHub of our code repo. So let's go ahead to code pipeline. So if we create pipeline, you can see it will say new role and pipeline. We can do some name and then so it will automatically create the role name also. So then if you create next, you can choose as GitHub version, any version, and you will connect to GitHub. And so that's how you go ahead with the AWS code pipeline. So we'll go back to this. It's very simplistic. Once you follow the instructions, we authorize Git repository and select AWS code build. So in the final step, you will select code build as a builder. So that's all you do. So basically you are saying the code pipeline puts together the code build, the GitHub repo, and you're saying that using this GitHub repo, you will use code build project to build this data and then pass it on to the code deploy, which will deploy it on this EC2. So now let's go to code build. Basically you're choosing that the build has to happen on a Linux environment and a standard runtime environment, and the image, we should select the latest image. Let's go ahead and see what we are talking about. Code build project. I have already created the code build project. So again, very straightforward. Whatever is mentioned there, you just follow. We are saying that code pipeline will be the build provider, and this is the name, and there is no tag, and you are saying that this is the Linux environment. We are using Linux, and this is the role that we have assigned. And we are using buildspec.yml to build the data. Again, if you remember, we went through the buildspec.yml, and that's what we are mentioning here. So let's go back to our instructions. We have chosen Linux and runtime standard and latest image. It will create a new service role like we mentioned for code pipeline as well. And you just mentioned that you will use buildspec.yml. Configure the deployment provider and select code deploy as the deployment provider. So once you build, how do you deploy it? So you just select code deploy. So in pipeline, you're choosing code build as your code builder, and in code build, you're using code deploy as your deployment provider. And code deploy, we already mentioned which EC2 use. So we have to use the tag of the EC2 to deploy, right? So configure the deployment provider as code deploy, and the application and deployment group will be the ones we created before. And then once we create it, it will initiate a process and it will download all the Maven dependencies and build the jar. So it will look something like this. So it will build the jar. It will download all Maven repo. If you look at the log file, so basically the dependencies for your application, right? So once you do this, let's go ahead and we are set up with the application, and let's go ahead and run our pipeline. So our pipeline would be set up, would be ready. So this is the pipeline that we created using the above mentioned steps, and you will see a like a component here, which is the initial GitHub data, and then the code build process, which will build the data, and the code deploy process that will deploy the data. So this entails the code pipeline, and the deploy finally deploys into the EC2. This is what we have using the tag EC2 tag, and the build gets the data from the GitHub repo, and then it builds using the build.yml app build.yml, right? So let's go ahead and see what is there in the app build, right? Build spec.yml, yeah. So it will use it to do mvn test and mvn package. So let's go ahead and see. So basically it is executing those line and these mvn test and mvn package spring boot repackage that we have mentioned, and to set up Java in the build environment in the build spec.yml. So as you can see, it is executing those steps, and it is downloaded the libraries, and it is also will also run the test mvn test, whatever is we have mentioned. So we have a single file, single REST controller for which we have provided a simple test class. So it will be running that test also. So as you can see, test run 1, failures 0. Basically there is a single home controller test. So if you want to see what is there in home controller test, let's go into the src folder, test Java, and it's a simplistic JUnit test. I'm just saying that if the whatever the home controller dot home method returns is hello world or not. So that's all we are doing here. So as you can see, it's like a continuous integration and continuous like Jenkins. It will run the build, it will run the tests and deploy the application, and also it will help you configure the various aspects of the CI/CD build. So now let's go ahead and do some change to our application and see if that triggers a build. So let's just change the readme file. Say done, and then final check-in to readme. So let's say that and commit our change. And now let's go to the code pipeline and see. As you can see, it automatically initiated a code pipeline process. So it will run all these 3 steps: source, build, and deploy steps, and it will deploy that data to the EC2 instance. It's gonna take a while. In the meantime, we'll go into the EC2 and see whether our log file was created or not. So as you can see, you have a my.log file that is created because we enabled access logs as also. So it created a Tomcat folder and it has logs also there. So we have access logs which we provided as command line arguments when we run the jar file, execute the jar file. We could choose to put them also in CloudWatch, but right now I just put the my.log file to the CloudWatch. Let's see what's happening to my.log file. So it has the log outputs. So what should happen is once the application is deployed, we should be able to demo the PKCE authentication using the encrypted KMS encrypted password, and then we should look at the log files in CloudWatch. So I think it's the final step. It is deploying to the EC2. And let's go into the CloudWatch console and see what is there once. So if you remember, we had given CloudWatch permission to our EC2. Permission basically assigned the CloudWatch permission to our EC2 role that we created earlier. Let's go into the log groups. And basically I created this group, and the reason being this particular group name is what we have in the Amazon CloudWatch agent.json. So this is the log group name that we are supposed to create. So this is the same Java AWS R&D UAT logging and the UAT logging group that we created, and then we have a logs coming up here. For this we can attach Grafana or any other monitoring tool or graphical tool with graphical interface that can get a lot of trends, or you can do monitoring on it, check for errors or look for patterns, etc. So as you can see, it is putting the my.log file into the CloudWatch. So now let's go ahead and check whether the code pipeline is ready or not. So yeah, so you have got 3 tick marks. That means the code pipeline has completed the source, build and deploy processes. Let's go ahead and test our application. So basically I have used the public IP and the port is 8080, and I'm doing the authorize request to our PKC authentication flow, and it will take us to a login page, and once I click sign, it should give me a code. See, the logs are rolling, as you can see, and you can see that it has a call for authorize has happened. Now let me go back, copy the code. I have a postman, as I mentioned in my previous PKC demo. And this code verifier and code challenge we have already created. So I'm not going to go through that. Now once I send a request, I'm getting the access token, and basically the password you entered is being checked against the encrypted password in the application, and it is authenticating the user using the authorization headers also, client ID, client secret, and the code that is being given here. And now as you can see, OR token, it has returned the token. So that's about it for today's session, friends. Please support me for making any for more future interesting sessions. Thank you so much. Bye bye.